5 grams in robotics, enabling the automation revolution. Title: 5 grams in robotics, enabling the automation revolution. Introduction. The world we live in today is witnessing a rapid advancement in technology, especially in the fields of telecommunications and robotics. As the fifth-generation wireless technology, 5 grams, becomes more widely adopted, it is poised to revolutionize many industries by enabling faster and more reliable connections. One sector that stands to benefit significantly from this transformative technology is robotics, where 5 grams can pave the way for an automation revolution. In this article, we explore how 5 grams and robotics are intertwined and discuss the potential implications of this advanced connectivity. For various applications. 1. Enhanced connectivity. The advent of 5 grams brings unparalleled speeds and minimal latency, opening up exciting possibilities for the robotics industry. With its faster data transfer capabilities, 5 grams allows seamless communicate between robots and other connected devices. This enhanced connectivity empowers robots with real-time data processing, ensuring faster decision-making and improved overall performance. Whether it is in manufacturing, healthcare, or logistics, 5 grams enables robots to rapidly exchange information, leading to more efficient and effective automation processes. 2. Remote operation and control. One of the game-changing aspects of 5 grams technology is the ability to remotely operate and control robots. With its reduced latency, 5 grams networks enable real-time interactions, making it possible for experts or operators to control robots from a distance. This remote control capability opens up new avenues for disaster response, hazardous environments, and complex procedures. For instance, in scenarios such as firefighting, 5 grams powered robots can be deployed to assist in rescue missions, reducing risks to human lives. 3. Collaborative robotics. Collaborative robots, or cobots, are designed to work alongside humans, enhancing productivity and safety in various industries. The implementation of 5 grams wireless networks further enhances the potential of cobots by enabling seamless cooperation and coordination among multiple robots and human workers. This synergy becomes possible due to the high bandwidth and quick response time of 5 grams, allowing real-time data exchange, sensor feedback, and synchronized actions. In manufacturing, cobots can work alongside human operators in intricate tasks, minimizing errors and increasing production efficiency. 4. Smart cities and infrastructure. 5 grams technology enables the creation of smart cities, which rely on various interconnected devices and systems to enhance urban life. Robotics plays a crucial role in monitoring, managing, and maintaining these smart environments. From autonomous drones conducting inspections to robotic surveillance systems ensuring public safety, 5 grams connectivity capabilities empower these robots to gather and analyze data efficiently. As cities become smarter and more automated, 5 grams networks will play a vital role in robotics-driven urban transformation. 5. Healthcare and telemedicine. In the healthcare sector, the combination of 5 grams and robotics holds immense potential. Telemedicine, for instance, allows doctors to remotely diagnose and treat patients, even in remote areas. With 5 grams, Networks, the connection between healthcare providers and robotic surgical systems can be significantly enhanced, ensuring real-time communication and precise surgical procedures. 6. Manufacturing optimization. The automation revolution enabled by 5 grams and robotics extends to the manufacturing industry, where optimization and efficiency are paramount. With 5 grams enhanced connectivity, robots can communicate in share data in real time, allowing for seamless coordination on the production line. This connectivity enables robots to work collaboratively, autonomously adjusting their movements based on informa tie-in received from other robots and sensors. The result is increased production speed, reduced errors, and improved quality control. 7. Agricultural advancement. 5 grams and robotics have the potential to revolutionize the agricultural sector, addressing critical challenges such as labor shortages and increasing productivity. Connected robots equipped with sensors and cameras can monitor crops, soil conditions, and climate variables in real time. This data can then be analyzed to optimize irrigation schedules, detect crop diseases early, and precisely apply fertilizers and pesticides. Furthermore, autonomous robots can perform repetitive tasks such as harvesting and weeding, reducing the reliance on manual labor. By integrating 5 grams technology, robots in agriculture can operate with higher precision and efficiency, leading to improved yields, reduced costs, and sustainable farming practices. 8. Transportation and logistics. The integration of 5 grams and robotics in transportation and logistics has the potential to streamline operations and revolutionize the supply chain. Autonomous vehicles and drones equipped with 5 grams connectivity can communicate with each other, enabling efficient traffic management and route optimization. In warehouses, robots powered by 5 grams can navigate autonomously, pick and pack items, and collaborate with human workers seamlessly. This integration leads to faster delivery times, reduced costs, and improved inventory management. Additionally, 5 grams powered drones can be utilized for last-mile deliveries, further enhancing the efficiency and speed of logistics operations. 9. Education and skill development. The automation revolution brought about by 5 grams and robotics also impacts the field of education and skill development. With the advancements in automation technologies, there is an increasing demand for individuals skilled in robotics and its associated fields. 5 grams powered robotics can enable remote learning experiences, allowing students to interact with robots in real time through virtual simulations. This technology empowers students to develop hands-on skills and gain practical experience, bridging the gap between theory and real-world implementation. 10. Ethical considerations and challenges. While the integration of 5 grams and robotics brings numerous benefits, it also raises ethical considerations and challenges. One of the concerns is the potential displacement of human workers as automata increases. It is crucial to develop strategies to ensure a smooth transition and provide opportunities for upskilling and reskilling. Additionally, there is a need for ethical frameworks to govern the use and application of robotic systems, particularly in sectors such as healthcare and AI-driven decision-making. Balancing innovation and technological progress with ethical considerations will be crucial to ensuring the adoption of 5 grams and robotics benefits society as a whole. 11. Environmental impact. Another aspect to consider in the integration of 5 grams and robotics is its potential environmental impact. As industries embrace automation and rely more on robots powered by 5 grams, there is a potential foe. Our improved energy efficiency and reduced carbon emissions. With precise autonomous movements and real-time data analysis, robots can optimize energy consumption, minimizing waste and inefficiencies. In agriculture, for example, robots can use sensors and AI algorithms to precisely apply fertilizers and pesticides, reducing the need for excessive chemical use. Additionally, the use of autonomous electric vehicles powered by 5 grams in transportation and logistics can contribute to a greener and more sustainable supply chain. By leveraging the power of 5 grams and robotics, industries have the opportunity to reduce their carbon footprint and contribute to a more environmentally conscious future. 12. Security and privacy concerns. With the increased connectivity brought by 5 grams and robotics, security and privacy concerns become more prominent. As more devices become interconnected, the risk of cyberattacks and data breaches incorporated. RESAs. It is crucial to implement robust security measures and encryption protocols to safeguard sensitive data and prevent unauthorized access. Additionally, privacy concerns arise when robots with cameras and sensors gather vast amounts of personal or sensitive information. Clear regulations and guidelines must be established to protect individuals' privacy rights while ensuring the